Today we're going to look at right triangle trigonometry ratios. There's actually 6, but we're only going to cover sine, cosine, and tangent for this little quick lesson. So here we have a right triangle. Remember that little 90-degree angle there symbol is for 90 degrees, and that means you have a right triangle. Sine, cosine, tangent, trigonometry ratios only work for right triangles. That is not a right triangle, so we could not use sine, cosine, and tangent. So here we have this acronym called SOHCAHTOA, and we say that sine of theta is a ratio of sides, where the opposite side is in the numerator and the hypotenuse is in the denominator. So we're comparing the length of the opposite side compared to the length of the hypotenuse. So that's your sine. Your cosine of theta is the adjacent side compared to the hypotenuse side. So it's a ratio of how long is the adjacent side compared to the hypotenuse. And tangent, or tan, but we call it tangent. So we never say sin or cos, we call it sine, cosine, tangent, is the opposite side over the adjacent. So how long is the opposite side compared to how long is the adjacent side? So these are the ratios that you need to remember: sine, cosine, and tangent. And so we use this little acronym to help us remember how that the opposite over the hypotenuse is when it's sine. When we're talking about cosine, it is the adjacent side over the hypotenuse. And when we're talking about tangent, it's the opposite side over the adjacent. So that's how we get that little acronym. So what do we mean by sine, cosine, and tangent? Let's say we were looking out from angle B and referring to angle B. Wouldn't it make sense that the side that going out from angle B, that AC would be considered the opposite side of angle B? The side that is next to angle B is considered the adjacent side. So BC is considered the adjacent side. And the side that is always away from the 90 degrees or on the other side of the 90 degrees, so that means AB in this triangle, is actually called the hypotenuse. Now, opposite and adjacent will change depending on which angle you're referring to. We refer to angle B. What if we do it again this time, but we refer to angle A? So if we're referring to angle A this time, then that means, isn't BC considered the opposite side of angle A? And next to angle A would be AC, would be considered the adjacent side. And AB is still the hypotenuse, because the hypotenuse, again, is always away on the other side of the 90 degrees. It's always the longest side, too. Hypotenuse is always the longest side. So let's see how that would work. So for an example, if I asked you to write the ratio of sine of B, and then write the ratio of cosine of B, and write the tangent of B, do you remember how this works? So if I want to write the sine of B, that means I am referring to this angle here, which is B, because that's the angle they are asking me to look at. And remember, if you look at SOA, that means it's opposite side. So opposite side goes in the numerator, and the hypotenuse of the triangle goes in the denominator. So if I said this is 3, 4, and 5, then wouldn't the opposite side be 4? So doesn't 4 go in the numerator? And isn't the hypotenuse 5? Because it is opposite or across from the 90-degree angle, and it's also the longest side. So 4/5 is considered the ratio, the sine of B is 4/5. If we look at the cosine of B, doesn't it say that the cosine of B is the adjacent in the numerator over the hypotenuse? So the adjacent over the hypotenuse, that means the adjacent side should go in the numerator and the hypotenuse remains in the denominator. So isn't 3 the adjacent side to angle B? Because remember, we're looking at angle B. So 3 would be considered the adjacent side, and 5 is the hypotenuse. Tangent B. Let's clean this up and look at tangent B. Tangent B, we're looking at angle B again. And we said this is 3 feet, 4 feet, 5 feet. Remember, for tangent, it is the opposite side of the angle B and the adjacent side to angle B. So it's the opposite and adjacent. So isn't the opposite side of B 4? And isn't what's next to angle B 3? So notice the hypotenuse is not being used in this problem. It says the opposite side goes in the numerator and the adjacent side goes in the denominator. And those are your 3 trig ratios. We could do it all over again, and I won't do all of them. But what if I say to find the cosine of angle A? So doesn't that mean we're referring to angle A? And wouldn't we go and say we're looking at cosine? Therefore, doesn't the adjacent side of angle A go in the numerator? And the hypotenuse go on the denominator? So if we're looking at angle A, the adjacent side is what is next to angle A. So this is the adjacent side. This one would be the side that is opposite, and 5 would be the hypotenuse. But for cosine, it is the opposite side in the numerator and the hypotenuse in the denominator. So let's see if you can build some trig ratios. Next slide. Why don't you please pause and take notes and see if you can answer what's the sine of R, the cosine of R, tangent of R, and then sine of P, cosine of P, and tangent P. So what would be the ratios according to what we just learned about SOHCAHTOA? So what's going to be the ratios for each of those? And remember, that to help you remember, it's SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So pause the tape and then come back and let's start again. Okay, so did you say if we're looking at sine of R and we're looking at R, that means we're looking out here. So doesn't it say the opposite of that has to go in the numerator, and then the hypotenuse has to go into the denominator? So it might help if you write out that this is the opposite side of angle R, and isn't this side the adjacent side to angle R? So sometimes it's helpful to label them as hypotenuse, opposite side, and adjacent side. And then you can start filling in all your ratios. So we need to do 10 because 10 is the hypotenuse because it says to be opposite over hypotenuse. And then you should always reduce, right? So you should always reduce. So the final answer, if you reduce by 2, would be 4/5. So your ratio should always be reduced ratios. So cosine R, remember, is the adjacent side. So the adjacent side is 6 and the hypotenuse is 10. And when we reduce by 2, we get 3/5. Tangent, remember, is opposite over adjacent. So the opposite side is 8 and the adjacent side is 6. And we can reduce by 2 and that gives us 4/3. So if you didn't do very good, pause the tape and go and do 4, 5, and 6 over again, or double check your answers for 4, 5, and 6. So this time we are looking at sine of P. So we actually want to focus on the angle P. And the angle P is right here. So this is the angle that we're referring to. So we're looking at this angle. So again, isn't this always the hypotenuse? Because number one, it's the longest side, and it's always opposite the 90-degree angle. This side is opposite angle P, so we consider 6 the opposite side, and the side that is next to P is the adjacent side. So when we're talking about creating a ratio for sine P, then 6 is the opposite side and 10 is the hypotenuse. Because remember, it says opposite over hypotenuse for sine. And that reduces to 3/5. The cosine, remember, is the adjacent over the hypotenuse. And 8 is the side that's next to P. And 10 is the hypotenuse. When you reduce by 2, you get 4/5. And tangent P is the opposite over the adjacent. So that means that would be 6 over 8. And that reduces to 3/4. So do you remember? And does that make sense? Maybe go back and re-pause and go back and rewind if needed. Let's go to the next slide. Copy this triangle DEF and see if you can add to the diagram the lengths known given. Sine of 20 degrees is the square root of 14 over 11. Pause the tape, see what you can do, and come back. So here we go. Did you think of what SOA meant or sine meant? And remember that sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent. So we are working with the sine of 20 degrees in this problem. So that means we need to have the opposite side over the hypotenuse. So doesn't that mean that the numerator represents the opposite side of 20 degrees? And the 11 represents the hypotenuse of the triangle. So therefore, if we are looking at the opposite side of 20 degrees, doesn't that mean that the square root of 14 should be opposite of 20 degrees? So the square root of 14 should be placed on the opposite side of 20. And the hypotenuse is 11. And isn't the hypotenuse always directly across from the 90-degree angle? Did you do? How'd you do? Okay, let's go to the next slide. Last slide. Can you pause the video and see if you can answer this question? If you have this triangle, simplify this expression. So take a moment, pause the video, and see if you can figure this out without even me showing you, and then come back and see how you did it. Okay, so we have a 3 in the numerator. So I'm just going to recopy the 3. But doesn't this say sine of C? And isn't C this angle here? So don't we need to set up a fraction inside a fraction? And inside this fraction, shouldn't we have the opposite side over the hypotenuse? Because that's what this denominator is. This denominator is sine of C. And so shouldn't there be a ratio that represents sine? Right? So in the numerator, we need to put the number that is the opposite of C. And so if we're looking out from C and looking straight out, wouldn't 3 be the opposite side? And so doesn't 3 go in the numerator? And isn't 5 the hypotenuse because it's the longest side, and the hypotenuse is always across from the 90-degree angle? So wouldn't that make that 3 divided by 3/5? So you should always simplify when you have a fraction within a fraction. That's called a complex fraction. So remember, this division bar is just a fancy way of saying 3 divided by 3/5. And how do you divide fractions? Don't you put a 1 underneath that? Don't you change division and multiplication? And don't you reciprocate or flip the second fraction? And then don't you multiply straight across? And that gives you 15, and you multiply straight across. And 3, and doesn't that reduce to 5? You could have cross-canceled and then got 5, right? So you could have cross-canceled first before you multiply. So now that you understand that, why don't you pause, and why don't you try number 2 and come back, and let's see if you can do it right. So let's try the last problem. So if we have a 2 in the numerator, but we want cosine of c. So isn't cosine of c this time? So let me erase. Isn't cosine, right? So it's so, ka, toa. So cosine is the adjacent side over the hypotenuse. So that means this fraction should be the adjacent side over the hypotenuse. And since we're looking at angle C, the adjacent side is the side next to it. So 4 should go in the numerator, and the hypotenuse is 5 again. So that's what you get. You get 2 divided by 4/5. So we can write that over 1, and then change division and multiplication and flip the second fraction. Multiply straight across, reduce by 2, and there you go, 5/2. Okay, this is a quick little review of right triangle trigonometry using sine, cosine, and tangent. Sakatoa.